So in this video, I'm going over the vocabulary for Chapter 11. So you will need the Chapter 11 tip chart. And so we'll get started. All right, so a polyhedron. A polyhedron is, they call it a space figure. Space just means that it's three-dimensional. So it's a space figure or 3D figure, three-dimensional, with surfaces that are polygons. With surfaces that are polygons. So in this case, all the surfaces, they call them the faces. They're all squares, and here they're all triangles. You can have a mixture. And so I put in parentheses here some terms that they use about a polyhedron. Plural is polyhedra, by the way. So these are terms that kind of go along with a polyhedron. The faces of the shape are the polygons themselves. And then the edges of the shape, the edges of the three-dimensional shape, are the segments. And the vertices, plural of vertex is vertices. There's no such thing as vertexes. The vertices are the points. Sorry, ran out of room there. So I will highlight some of that stuff. This is called a face. That is a face. This is called an edge. Edge. And this is called a vertex. So all the points around the shape are the vertices, all the segments around the shape are edges, and all the polygons are faces. So if you want to, you can highlight those on this shape too. Here's a face, here's an edge, here's a vertex. Okay, so the next thing they talk about is the term cross-section. A cross-section is the intersection of a three-dimensional figure and a plane. So of a solid, I'll explain that word in a minute, and a plane. It's basically a slice of a solid. Okay, the reason I use the term solid is because up here, the term polyhedron, it says all the faces are polygons. Well, there are some three-dimensional figures, sorry, that spacing's bugging me. There are some three-dimensional figures that have faces that are not polygons. Like this one, for example. This face is a circle, and this face is a circle. And spheres, it doesn't have any faces, but it's three-dimensional. So they call that big family of shapes, the polyhedron and all the ones that contain circles, they call those the group of solids, of three-dimensional solids. So that's why I use the term there, solid instead of polyhedron. Okay, so it's basically a slice of this three-dimensional figure. So I drew a plane slicing through that cylinder there, and so it would make this slice right here. So if you were to just slice through that cylinder, it would cut out this circle right here. So that cross section is a circle, like that. That's that shaded circle. Now that's if you sliced it horizontally. If you sliced it vertically, it would not be a circle. So I want you guys to think about that. What if you sliced a cylinder vertically? Okay, so here's a cylinder. Okay, if we slice it this way, if we slice it across like that, we're getting that circle. But if we stand it up and slice it this way, what we'll get is we'll get a rectangle that's shaped like this. I don't know if y'all can imagine that, but it may help to think of, I don't know if when you guys were in elementary school, if you ever had one of your teachers do, if one of your teachers had you do stamp art, where you would like take an apple, cut it down the middle, and then you'd pick it up and dip that face of the apple into some paint, and then you'd stamp it onto some other paper. That's like a cross section of the apple. The stamp is what that cross section is. So So that might help you imagine that. All right, the next term is prism. So a prism is in that family of polyhedron, polyhedra, that's the plural. And so a prism has two bases, and those bases are congruent polygons. Congruent polygons. Two congruent polygons for bases, and then the lateral faces, the lateral or side faces, are all rectangles. Rectangles. All right, so this is a prism. See, these are the bases, the top and the bottom. Those are congruent polygon bases. Now, a rectangular prism is kind of a special case. You can really set it on any of the faces and it's gonna have a congruent one on the other side, opposite it. So really any of these opposite faces could be the bases of this figure. But we're calling these, the way that it's sitting now, we're calling those the bases. And see, this shape, this confuses people. A lot of people think this is a pyramid. But this is not a pyramid. This is a prism. It's a triangular prism because that face and that face, these opposite parallel faces, are congruent polygons. Those triangles match. So it's got two bases. Those bases are congruent polygons. Those congruent polygons are parallel to each other, and the lateral side faces are all rectangles. So if you were to flatten these out, the side faces are rectangles. So I made one like this for you just so you could see it, and I'll try to take it apart real quick. I taped it with painter's tape so y'all could see. So if I open this thing up, see the two bases are triangles, are those congruent triangles. That's the two bases right there. This one and this one. And then if you open up the lateral faces, see they're all rectangles. So rectangle, 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 and those rectangles wrap around to be the lateral faces, that's the side faces. And then these are the two bases, the top and the bottom. That's important to know because that's how the formula is built for finding the area of all these surfaces, called the surface area. All right, so that is a prism. Okay, a cylinder also has two bases, and those two bases are congruent circles. And they're also parallel. Those two bases that are circles are parallel, and it's basically got one lateral face, but that one lateral face is curved around. So one lateral face is a rectangle. And you may want to put that it's rolled up or that's curved around. I'm going to put rolled up. Okay, so here is a cylinder. If I were to cut down this side right here, and I probably should have prepped that so I could show you, but when you unwrap it, and when you cut down there and you just flatten it, it will be a rectangle. It's just rolled up. So here are the circular bases. And then if you unroll that, if you cut down the side and unroll it, you've got one rectangle that's rolled up, and then you've got this circle on the top and on the bottom like that. So that's what it would look like if you flattened it out. Okay. There are right ones and oblique ones. So all these shapes right here, there are right ones and oblique ones. Okay, so for that, if you connect the centers with a segment, and the same thing here, if you connect the centers with a segment, if that segment is standing straight up like these, perpendicular to the base, at a right angle to the base, then you've got yourself a right cylinder and a right prism. If that segment that you connect here, it would be that vertex connected to the center like that. It's a little bit hard to see, but it would be that line right there. All right, if you connect the centers of an oblique shape, it's not perpendicular to the base, it's leaning over, okay? So I'm gonna write that down. The segment connecting the centers, centers of bases, the segment connecting the centers of bases is perpendicular to the base. Now, sometimes it's two bases, sometimes it's one base, like in a pyramid. So the segment that's connecting the centers of the bases, or the one base to a vertex, is perpendicular to the bases. Or in other words, it's an altitude, okay? So if you draw a segment connecting the centers and it's an altitude or it's perpendicular, that makes it a right one. And then if it's not, that makes it an oblique one. So the segment connecting the centers of the bases is not perpendicular to the base or the bases. Okay, so I put centers of the bases, but sometimes it could be a vertex to a center of one base, if it's that kind of shape. So yeah, if it's standing straight up, it's right. If it's leaning over, it's oblique. All right, the next term is lateral area. The lateral area is the area of the lateral or side faces. The lateral or side faces. And in the formula, I'm going to go ahead and write this down even though we're not talking about formulas yet. It's basically perimeter of the base times the height. I'm going to talk about that for just a minute. Okay, in a cube, for example, no, I could be talking about other shapes, but in a cube, the two bases, if you ignore those guys, if you ignore the top base and the bottom base, the rest of it is the lateral area. It's the side area, basically. So it's the area of that shape, that front one, this one on the right, this one on the back, and this one on the left. And so I flattened it out for you. I drew what's called a net of that cube. This is the lateral area. Now let me explain to you why it's pH, okay? To find the area of this rectangle, which is really what that lateral area is, it's just those four rectangles that are put together to make one big rectangle. See, when you unwrap this, those are still connected. And so it's one big rectangle. And one big rectangle would be length times width, right? Or base times height. So see, this base right here times this height right here would give you that lateral area. And so this base right here, though, if you imagine that it's put back together again to be this cube, isn't it this line right here? That line right there. When you unroll it, it gives you that segment. So that distance around here, when you flatten out that that cube into its net, that's that red segment right there, okay? And that's base times height. Well, that's just the perimeter of the base. And so that's what this means. That means perimeter of base. Times the height of the actual cube. That's how tall the actual cube is. So we'll talk more on that when we get to the formulas, but that's how to find the lateral area, is the perimeter of this base times the height of the prism. That'll give you the area of the lateral faces. And then this one, it would be the perimeter of this triangle times how tall it is. That would give you the area of those rectangles that are going around this prism. That's a little complicated. More on that when we get to formulas. Okay, surface area. Some books call this total surface area. So there's a reason for that. And so some books you'll see it written as capital T, or on some formula sheets they'll call it capital T. All right, so here's what total surface area is. It's that lateral area that we talked about, the side faces, plus the two bases. So it's the sum of the lateral area. I always put laterate. It's lateral area and the bases. The area of the, I should say, and the area of the bases. Now, sometimes there's just one base, like with a pyramid. So it would be the sum of the lateral faces plus that one base. That is how to get total surface area. So I drew you a picture here. When you flatten out that cube, not only is it the lateral area, which is this part, but you would add this base and this base. So the way we could write that in this case is perimeter of the base times the height. That would give you the lateral area, plus two capital B, they call that, because it's two bases. So you'll notice that when we get to the formulas. Okay, the next one is a pyramid. So notice a pyramid only has one base. And on the opposite end, the opposite side from that base, sorry, I'm having to stop my dogs from fighting. Stop it. Let him go. Let him go. Sorry about that, guys. All right, so there's a point on the opposite end of that base, okay? So here's what a pyramid is. Now, there's a big old long definition if you look up the definition of a pyramid in your book. I'm just gonna highlight the good stuff, okay? There's one base that's a polygon. One base is a polygon, so it doesn't have two congruent bases, it just has one. And the lateral faces are triangles. The lateral faces are triangles. So that those side faces, so the faces that go around the side of it, those are all triangles, and the base is a polygon. Now, you can have a square for a base. That's usually the pyramids that we look at. This is a triangular pyramid because the base is a triangle. You can have a hexagonal pyramid where the base is a hexagon. So there can be different shaped pyramids. It all depends on what shape the bottom is. Okay, a regular pyramid is a pyramid whose base is a regular polygon. So a pyramid with a base that's a regular polygon, with a base that is a regular polygon. And so the one that I drew for you, that is a pentagonal pyramid. This base is a pentagon, and it's a regular pentagon. See, it's got 5 sides. And so that's a regular pentagonal pyramid. All right, next one. This is a really, really important term because they use this term in the formulas, and it's kind of tough for people. So this is slant height. In formulas, you'll see it as a funky looking cursive L, or you might see it as a lowercase cursive s. I've always written it as a lowercase cursive L. Oh, my dog stole my pencil. Oh, goodness. Hey, Kale, can you get that pencil from the dog, please?